Okay, so I can't see anybody there, but hi. Um, you know, I was sitting there and I was looking at the trying to look at some planets, look at Saturn, look at Jupiter, and even in my good scope, it was just teeny tiny little dot. And so I started to look around and investigate, trying to get a change for that. And so I ran across Barlows and Extenders. And a lot of the time, I find people that don't really know too much about focal length or the F number, how fast their scope is. And I really didn't bother with a bunch of that stuff either. So as I was buying I bought a set of extenders, 2, 3, and 5 times extenders. And I thought I'd like to figure out why and what's happening and what does it all mean and how does it work that way? Because when I talk to people, they say, "Oh, you have a telescope? That must make things really big." And well, not necessarily. It depends on your scope. So first, a little bit of background. All scopes have an F number. That's F4, F7, F15. And the lower the number, the faster the scope. The lower the number, the less light it well, the more light gathering capability it has. So if you gather a lot of light and you're exposing something, then it's faster. It's a faster exposure. So when you're looking, the first thing is the scope. It's the diameter. It's actually the area, but we look at we measure the scopes in diameters. For example, our big scope at the observatory is, anybody remember how much it is? It's 14 inch. So it's 14 inches, 355 millimeters. I have one scope at 106, and I have another scope at 80. And oh yeah, and my Equinox is at about 100, 104, I think it is. So the wider the aperture, the more light you're going to bring in. So a general rule of thumb is if you have everything else equal and you make the scope wider, in other words, by buying another scope, it goes faster and the F number will drop. Now, the other aspect is focal distance. When the tube gets longer, it gives you a narrower field of view, typically, usually, almost always. And the focal distance is increasing. And the longer, the more difficult it is for the light to get through a long, slow tube, the slower the number will be. Now, there's an equation, and I'm only going to do 2 equations just to show you the relationship. We have an opening size, or the aperture, and that's fixed for your scope. You can't blow air into it and expand it. And that is equal to pi times the focal length divided by 2 times that speed number, the F number, squared. So if we increase the focal length, in order to have the same aperture size, that means the F number will have to also increase. So they'll move together. Now, some of us get annoyed when the non-telescope owning people come up and say, "Oh, what's the magnification of your telescope?" And That's because the scope is one part of it, but the eyepiece is the other. And how to tell what magnification you're getting is the focal length of the telescope divided by the focal length of the eyepiece. Okay, so all else equal, the longer the telescope focal length, the higher the magnification. Okay, you can see that in the equation. As you increase the focal length and you're keeping the eyepiece the same, the magnification will go up. Now, does anybody remember the effective maximum magnification that we can have on the surface? Well, I can't hear you anyway. Think in terms of um, the multiplication, sorry, the millimeter diameter. That's about the maximum effective magnification your scope is capable of giving. After that, and actually after about 400 times, it's the atmosphere that becomes the weak link in the equation. So how big is your telescope? Is it short and wide, like the one at our observatory, which is an f2? So that's a big scope. It gathers a lot of light, and it's quite fast. f2 is quite fast. And then I chose this other scope here to show you what a long, skinny tube where you can see that you're not getting a lot of light in because it's a small area. And that actually is an f15 tube. But what happens if you're like me, that has a relatively short, moderately narrow scope? I see faint DSO, but it's not great for small things like Jupiter or Saturn. It's not ideal. So am I stuck at looking at big things that are faint? Am I stuck at looking at deep sky objects? No. This is the, if you're ever looking, it's a site called Astronomy Tools, and you can put in all sorts of different configurations, and you can test out various equipment and eyepieces and Barlows or extenders and cameras, and you can see what the image in the scope should look like. So this is Jupiter, in case you couldn't tell from the little picture. And here it is, same scale. So this is a 3.5 millimeter eyepiece, which is the most powerful one that I have, 560 millimeter focal length. And then I added a 5 times extender. And that's the image size that I'm now getting. I can now put a camera on that, and it's more than 5 or 10 pixels wide. It's a good size. So what is a Barlow lens? Oh, that's a Barlow lens. That's a 3 times Barlow. It costs about $120 US, and it'll give you about a 3 times magnification. It's not 100% equivalent when you're looking at the multipliers. For example, a 5 times extender can give you up to 7.7 times magnification. So this Barlow, the Barlows are cheaper than extenders. And what's the difference? Well, here's a cross-sectional view of a schematic view of a Barlow, and you can see the red V going in. That's the light coming in from the aperture and comes in, and as soon as it hits that front diverging lens, it changes direction. It changes the direction, it inconveniences the photons as if they were coming in through a much longer scope, or a scope that has a lot higher focal length. And that means it comes down the tube and goes into the eyepiece, and the effect that you see, apart from a bit of dimming, is an increase in apparent magnification. Okay, so all we're doing is we're inconveniencing the photons. But for your shorter, faster scopes, it'll give you an expanded image. Now, if you look at the light pattern inside the tube there, you can see that it is convergent and then divergent. That means that your pupil distance is going to change. So you will get an apparent increase in eye relief, which means you're going to move further away from the tube, which means sometimes in Barlows, if you have a really fast small scope and you're using, and you put the Barlow in and it's a lot higher magnification, you start to get vignetting of your image. So your image is constrained by the size of your eyepiece tube. So then, what's an extender? Well, I saw one page and that tried to explain it, and they said, well, it's really just an uptown Barlow. What an extender does is it too alters the light path, but it, instead of that convergent divergent, it changes it so it's called parfocal. It makes the light parallel. Instead of convergent, it parallels it through two doublets on one end and two doublets on the other. Sorry, a doublet on one end and a doublet on the other. So there's 4 elements inside an extender, at least 4 elements inside the PowerMate extender. So this provides a magnification increase without moving the pupil position. You'll look through your eyepiece just as if you were looking at it without the the extender there. Only what you'll see will be a heck of a lot bigger. It'll also be dimmer. And that's an advantage if you're looking at hydrogen alpha. Sometimes you're looking at the sun doing solar observation, and you're looking at the sun, and the sun is really bright, even in the scope. And you can put this in, and not only does it bring you a lot closer, does it increase the magnification, but it also cuts down again on the light that you're seeing. It slows down the scope, and it can make it easier to see the surface features on the sun. So you got to then ask, if I want to buy an extender, what do I buy? I see they offer 2 times, 3 times, 5 times, 2.5, 1.5. They have a wide variety of Barlows and extenders. Is more magnification better? No, it's actually not better. There's an optimal magnification for your scope and viewing conditions. The darker it is, the more magnification you can get away with before the atmosphere starts to interfere. So what is optimal? Well, take that F number that we talked about at the beginning and multiply that times the extender or Barlow magnification, and it should be someplace ideally around 15 to 20. If you have 13 or 22, is the image going to be terrible? No, shouldn't be. But it's the optimal range is someplace in between 15 and 20. For example, my f4 scope will be best at less than 5 times, but it can take more than 3, and that's why I bought both the 3 and the 5. There wasn't a 4 in what I was looking for. So, are there any questions this newbie can answer?
Yeah. Hi, Bill. So you may have said it and I missed it. I'm sorry, but if that's the case. So when you're looking at solar flares and so on, are you routinely using an extender or a Barlow?
I haven't had a good day to do that since I bought them.
Oh, okay. Well,
but I want to try it because I bought a camera. The biggest disappointment was, okay, I'm going to take pictures of the planets. I bought a camera, I looked through it, and it's still a little tiny dot. So I wanted to expand it out without degrading the image quality. So I bought a good teleview extender. But yes, what I've read is that you can put the extender on and zoom into the flares and uh, see them, image them a lot better. I haven't tried that personally.
So what does the extender do to the focal plane compared to the Barlow?
It keeps the focal plane in the same spot as it was.
Oh, okay. So if you're not using an eyepiece, then if you're using a sensor, it's not going to make any difference.
It shouldn't. And if you use the 5 times, Richard, what happens if you use the 5 times? The further back you put it, the higher magnification you're going to get.
Oh yeah, no, I get that. I was just, it's just always, I was curious to know how it affected the focal plane, because I mean, that's where you're going to put the sensor. Yep.
Yes.
Oh, that's interesting. Yeah. Okay. Thanks.
So my recommendation is spend the extra $100 and get an extender versus playing with the Barlows.
Yeah, I've used like 2 times Barlows, and the focal plane is way back sometimes. You know, like a short telescope that's maybe about 50, 60 millimeters long. You can add another 60 millimeters worth of extension tubes and spacers, you know, to where the image is finally formed.
Yeah. And with an extender, you don't have that issue.
Actually, Bill, I was just thinking about solar again. I believe it's the case that if you're using something like an Etalon for viewing the sun, they work much better if they're working with an extender with the parallel. So not just a case of whether you can find a focal point, but you just get better results with the extender.
Yes, I touched base with Lunt, the maker of my scope, before I got it too, and they recommended it.